Hello everyone, welcome to my YouTube channel featuring the Senior High School Mathematics. This time, I have two examples featuring the limits of the functions in indeterminate form part 2. I have these two examples to solve this in this video, okay? First example, the limitation of 3 over 2 plus h minus 3 halves all over h as h approaches the 0. Second example, the limitation of 3x all over x minus 2 minus 6 all over x minus 2 as x approaches to positive 2. Okay, so let's solve example number 1. Take note, observe that your h approaches to 0 as you use the direct substitution method. As you substitute the value of your h, which is 0, to all the variables h in the example, it will become indeterminate form. Take note, indeterminate form is the form 0, 0, meaning the values of your limit is indefinite, meaning all numbers in the number line. So what are we going to do if your function becomes indeterminate is to go back to your original function. Take note, this is my original function. That is a fraction of a fraction, meaning double fraction in the problem. So what are we going to do? Let's rewrite our original function. Our original function is 3 all over 2 plus h minus 3 over 2 all over h. What are we going to do is to simplify, evaluate, and investigate our original function. Because when we use the direct substitution method, it will become indeterminate form. Take note, you have this numerator. This is the entire numerator, ladies and gentlemen. And your denominator is h, okay? So what are we going to do? Let's combine our numerator as one fraction. Again, combine your numerator as one fraction. Meaning, we are going to look for the LCD or the least common denominator. Your numerator is in the form of 3 all over 2 plus h minus 3 halves. Okay, let's find our the least common denominator. Take note that our first denominator here is 2 plus h, and our second denominator is 2. There is no common factor of these two denominators. So the best way to look for the LCD or the least common denominator is to combine our two denominators. So meaning, let's combine it. So the first one is 2 plus h, and the other one is 2. Okay, that is now our LCD for these two fractions. After looking for the LCD, let's now combine our two fractions. What are we going to do is to divide your LCD to each of the fractions. Okay, again, to divide your LCD to each of the fractions. So just follow me. Okay, this is how are we going to do. 2 plus h times 2 divided by 2 plus h. Again, you are going to divide your LCD to each of the denominator. So 2 plus h times 2 divided by 2 plus h. And basically, you can cancel out 2 plus h, right? What is the remaining value is 2. Okay, again, you divided 1, you cancel out 2 plus h, and you still have 2. What are you going to do with 2 is to multiply to your numerator. So meaning 2 plus times 3, that is 6, right? Okay, what are you going to do next is to copy the operation. You have a subtraction sign, so meaning you have to copy that 1. Okay, am I clear to everyone? That's good. So now, we are done simplifying to our first fraction. Let's proceed to our second fraction. Same thing. We are going to divide our LCD to our second fraction. Okay? This one divided by 2, obviously you can cancel out 2, right? What is the remaining quantity or value is the 2 plus h. Afterwards, you are going to multiply that 1 to your numerator, which is 3. Again, you divide this 1 to the 2, and obviously, you can cancel the value of 2. What is the remaining LCD part is the 2 plus h. After you divided 1 to your LCD or to your denominator, you are going to multiply that 1 to your numerator. Okay? So again, your numerator here is 3. So you copy 3 and you multiply 3 by 2 plus h. Okay? Again, first rule, you look for the LCD. Second, you simplify each LCD in each fraction. Okay? So our new fraction now, our new numerator in our function is this one. So after that one, you copy h. H is your entire denominator. Okay? So now, after you simplify that one, continue simplifying, continue evaluating, and continue investigating. So look at your new numerator. Okay? Very obvious that you can distribute this quantity to the 3. Okay? So you copy x minus 3 times 2, that is 6. Okay? Negative 3 times positive h, that is negative 3h. Okay? All over to your LCD, which is 2 plus h times 2, all over to the entire denominator, which is x. Okay? Again, we simplify, we combine that one as one fraction, then we simplify your fractions. So afterwards, you continue simplifying. Okay? Obviously, 6 minus 6, that is 0. Okay? What is the remaining in your numerator is negative 3h all over the quantity of 2 plus h times 2 all over h. Okay? Again and again, continue simplifying, because once you substitute the value of your h, which is 0 here, your denominator is still 0, and that is undefined. You cannot find the value of your limit. So now continue simplifying. Observe in this form, you have a double fraction. Okay? First one, that is the first fraction. Second one, that is your denominator. Take note or remember that the value or how you simplify double fraction, most especially dividing double fraction. Okay? What are we going to do is to follow this rule. Rule number 1, copy your numerator. Take note, these are your entire numerator. Okay? You copy your entire numerator, which is 3h all over 2 plus h times 2, and you change. Obviously, this is your division sign. Again, step 1, you copy your numerator. Step 2 is to change division sign into multiplication sign. So we are going to change this division into multiplication sign represented by a dot. Okay? Third rule is you get the reciprocal of your denominator. Your denominator is h. What is the reciprocal of your h? That is 1 over h. So that is what are you going to copy? Again, you copy your numerator. This is your numerator. You change your division sign into a multiplication sign represented by a dot, and you get the reciprocal of your denominator, and your denominator is h. The reciprocal is 1 over h. So after applying the rules of dividing fraction is to apply the rules in multiplying fraction. So obviously, how to multiply fraction? A multiplying fraction, numerator to numerator, denominator to denominator. Take note, as you observe in this form, you can cancel out h because you are now multiplying. So meaning, you can now cancel out the value of your h. So what is the remaining value here is negative 3 times positive 1, that is negative 3. Okay? All over, obviously you already cancel out everything here. What is the remaining value is 1. Okay? 1 times this value is still the value itself. Okay? So that is 2 plus h times 2. Okay? So obviously, this is now the new form of your limitation. How are you going to assure that it is already the new function when substituting to the value of your h? Your h here is 0. Once you substitute 0 here to your new function, your function will not become the indeterminate form. Meaning, once your function is no longer indeterminate form, there you can conclude that the limit exists. We have now the limit. Okay, we are done simplifying this one. Once we simplify this one, there we can conclude that the limit exists. How are you going to know that the limit exists? Once you substitute where your variable approaches in this example, our variable approaches to 0. Once we use the direct substitution method in our new form of a limit or of a function, it will become negative 3 all over what is the value of your h, that is 0. 2 plus 0, that is 0. There, it is very sure that your denominator or the entire fraction is no longer 0 over 0 or no longer in the indeterminate form. Meaning, there we can conclude that the limit indeed exists. Meaning, there is a limit in this function. Take note that our new form of a function now is the limitation. This is now your new form of a function, that is negative 3 all over 2 plus h times 2 as your h approaches to 0. Okay, so now, how are we going to solve this problem? So we are going to use certain rules in solving this problem. So meaning, it will become the limitation of negative 3 all over the limitation of the quantity of x at 2 plus h times 2 as h approaches to 0. Okay, so now obviously for our numerator, limitation of negative 3, that is a constant rule, meaning the limitation of a constant is the constant itself, that is negative 3. Obviously, in our denominator, we can use a lot of rules. So first is the summation rule by distributing the limitation to 2 and distributing to limitation to h and to the limitation of 2. So obviously, it will become the limitation of the quantity of 2 plus h times 2 as h approaches to 0 is 2. What is the value where your variable approaches? Exactly, that is on 0. So times 2. So by simplifying, that is negative 3. 2 plus 0, that is 2. 2 times 2, that is 4. Therefore, for example number 1, that is the limit of that function is negative 3 over 4 or negative 3/4 as your h approaches to 0. Always remember, people, that once you use the direct substitution method and it becomes indeterminate form, do not directly conclude that the limit does not exist. What are you going to do? You go to your original function, you simplify what just like what we did, and you look to your new form and substitute your value of h. Once your form or your new function is no longer in determinate form, meaning there you can conclude that the limit exists and you can now apply the certain rules in solving that one. Okay? Am I clear to everyone? That's good. This is example number 1.